We're trying to put these numbers into the grid shown, so the product along each edge is the same. So first of all, let's multiply these numbers together. Now that won't actually give us the overall product because the corners are being used twice, but we can then bring that idea in and try to make the product the same by using larger numbers in the corners. So if I write things as a product of prime factors, I've got 2 times 3 times 2 squared times 5 times 2 times 3 to 6 times 2 times 5. This gives 1, 2, 3, 4, 5, lots of 2, so 2 to the power of 5, and then 1, 2, lots of 3, so 3 squared, and then times 5 squared. So one thing that comes about is we've got an even power of 5, so we must have a power of 5 on a corner and then one on an edge. So let's say I put 10 in. See, what I mean is if I have a 10 here, then I end up with a power of 5 along here and along here. So actually a consequence is that I'll need to put 5 there so that overall it will balance out. So let's imagine I put 10 in. I'll put the 5 in later on. So now my product of all the numbers, because I'm including 10 a second time, is going to become 2 to the 6 times 3 squared times 5 cubed. So what this number is, let me just explain, is it's going to be all of the three edges multiplied together, including 10, but I haven't yet included this one here or this one here. And I need all of the powers to be divisible by 3, because at some point I can cube root this, because basically I'm multiplying these together, but they all have to be the same. So I'm finding like x cubed. So I now want to include the next biggest number if I can, and also furthermore, the power of 3 is even, meaning I'm going to have to use I'm going to have to use a number involving a multiple of 3 at one of the corners, and then the other one at the opposite edge. So let's say I put 6 up here. Now I'm going to get 2 to the 7 times 3 to the 3 times 5 to the 3. And this is looking great because I've got my 3's and my 5's, because when I cube root this, I'll just get 3 times 5. See, I cannot, although I might want to put 5 here to maximize the corners, there's no way that I could then make them all the same, all the edges the same. So I'm going to go with the next biggest, which is 4, which will give me 2 to the 9, and that is what I want, times 3 cubed times 5 cubed. Because when I cube root this to give me the total for one edge, that's going to be x. I can cube root them separately. When I cube root 2 to the 9, well, it's actually 2 to the 9 is 2 cubed times 2 cubed times 2 cubed. So this becomes 2 cubed. I'm basically dividing the power by 3. This becomes 3. 3 cubed, cube rooted is 3, and then 5. So that is my theoretical largest product. I'm going to get 8 times 4, 40, 120. And let's just check. Like I said before, this has to be 3 to make the powers of 3 correct, and this has to be 5, meaning this is 2. Then you can just do a quick little check and see that 120 is possible. That is necessarily the largest total. We've used the largest numbers except for 5 because we saw we ran into a problem. It's all checked out from there, so it must be the biggest. Well done.